Okay, so we're moving into Unit 3 now. The topic of Unit 3 will be graphical and algebraic models. And the first one we're going to review is the linear model, which you first saw in grade 9 and have touched on each year since then. So I'm hoping that most of this will seem familiar to you. So first here we're going to go through a few points about linear functions. So the graph of a linear function we know is a straight line. And the most common form for the equation of a linear function is y equals mx plus b. And in that equation, m is the slope and b is the y-intercept. In the table of values for a linear function, we know that the first differences are constant, meaning the difference between each successive pair of y values would be the same. The rate of change for a linear function is constant, and the slope is a measure of that rate of change. So slope and rate of change mean basically the same thing. Next it says when the rate of change or the slope is positive, the quantity is increasing. Okay, so on a graph, that would be having a line that is going up to the right. When the rate of change or the slope is negative, the quantity is decreasing. So on your graph, your line would be going down to the right. And when the rate of change or the slope is 0, the quantity is staying the same. So there's no change in your y values. So that graph would just look like a horizontal line. Okay, when we are asked to find the slope, we can do that using various methods. First, we could look to the equation to see what the slope is. It would be the number in front of the x or the independent variable in your equation. Or you can use rise over run if you have the graph, or the slope formula. Okay, so you've got a few different ways of finding the slope. So first example here says a luxury car rental company charges a flat rate of $100 plus $1.50 for every kilometer to rent its vehicles. Write an equation for C, the total cost of the rental in dollars, in terms of N, the number of kilometers driven. So for that equation, we could say the cost is equal to, now it says they charge $1.50 for every kilometer. So if N is our number of kilometers, that would be $1.50 times N, plus our flat rate, which is $100. So plus 100. Now it says use a table of values to create a graph for this function using n values from 0 to 500. So when we create our table, whichever quantity we're putting on the x-axis, which in this case would be number of kilometers, goes on the left side of the table, okay, and then cost would be on the right. Okay, so 0, let's go up by hundreds, since we're going up to 500. Okay, and then to calculate our cost values, we're going to sub each of these values of n into the equation. So in our equation, if n is 0, the cost would be 100. If n is 100, so it would be $1.50 times 100 plus 100 gives you $2.50. If n is 200 in our equation, $1.50 times 200 plus 100 is 400. Okay, and you would continue that process to fill in the rest of your table. And those values are 550, 700, and 850. Now, just while we have this table of values handy here, I'll show you what I meant by the first differences in case you forgot what that was all about earlier in the lesson. So when you have the table of values for a linear function, the first difference is meaning the difference between each pair of successive y values will be the same. So in this case, we know we're going up by 150 every time. Okay, so that wasn't necessarily part of this question, but I wanted to use this example to point out to you. So let's make a little note here that the first differences will be constant. Let me try that again. First differences will be constant. Okay. Okay, so let's go back to our graph. So we're going to plot n, our number of kilometers, along the x-axis, c, our cost, along the y-axis. We need our n values to go from 0 to 500. And cost goes up to 850. Let's go up by 100s, but I'll just mark off each $200 increment up to 1,000. Then we'll plot our points as best we can. So we have the point 0 and 100, 100 and 250, 200 and 400, 300 and 550, 400 and 700, and 500 and 850. A little difficult without a proper grid. So then we have our graph. We could join those with a straight line, just like that. So we can see, again, that the graph of this function is a straight line. Now it says, what is the c-intercept? That would be like your y-intercept. It's just that on the y-axis we have cost this time. And what does it represent? So the c-intercept would be where your graph crosses the y-axis. So that point here. So that would be 100. And what does that represent? That would be your fixed cost, the fixed cost of your rental. So in other words, even if you don't drive any kilometers, that would be your fixed cost for renting the car. So this is the fixed cost of the rental. Okay. What is the slope with units, and what does it represent? Now, the slope can be found in various ways, as I was saying at the beginning of this lesson. So you could use the equation. That would probably be the easiest here. So scrolling back up to your equation here for a moment, we know that the slope is the number in front of your independent variable. So in this equation, the slope would be $1.50. Okay, so we'll say m equals $1.50. And our units for slope, when you are asked to include the units, let's just make a side note here. Okay, the units for slope are always the units on the y-axis over the units on the x-axis. So what I mean by that is, on your graph that we just created, the units on your y-axis are dollars, and the units on your x-axis are kilometers. So the units for your slope would be dollars trying to write a dollar symbol, it's just not working very well. Dollars per kilometer. Okay, would be your units. And what that represents is the variable cost you would pay depending on how many kilometers you drive. So this is the amount charged per kilometer. Okay, so one way to find the slope is from the equation. And I'll remind you back from the beginning of your lesson, you could also find the slope using the graph, using rise over run, or using the slope formula. And you have both of those methods at the beginning of your lesson. Okay, so determine the equation of the line in this graph. Okay, so here's where we'll need to use the graph to find the slope. Okay, and in order to do that, we're going to choose any 2 points on this line. So maybe I'll choose this one and this one. And find the rise and run between those 2 points. So moving from left to right, we would go down 2 and right 1 to get to the next point in the line. So our slope is going to be -2 over 1, or just -2. And the b value in our equation is the y-intercept, which we can see from the graph is 5. So b is 5. So therefore our equation will be y equals -2x plus 5. Okay, one other thing I wanted to note just before we finish up here is when you are using a graph to find the slope, so when you are using rise over run, you need to pay close attention to the scale on each axis. So let's make a note of that. When finding rise over run, pay attention to the scale on each axis. So in other words, sometimes your scale will be going up by tens or up by 100 and so on, and you need to take that into account when you are finding the rise and run. So each square, it does not always only represent 1. Okay, so you need to pay attention to what that scale is. And that concludes this lesson.